The topic for part 3 here is tree diagrams. Tree diagrams are basically a lot like our compound or multi-events that we had in the last part where we had more than one thing happening. The reason we do these, it's kind of a proof to show how it works. So for example, if I had the probability of flipping a coin and getting tails, rolling an even on a dice, and then flipping tails again. How we did in that last section was just this. I would list the tails chances and the outcomes, which would be 1 out of 2. The even on a dice, so it'd be 3 even numbers on a dice, so you'd have a 3 out of 6 chance of getting an even number. And then for the tails again, it would still be 1 out of 2, and then I would just multiply everything together. So that top number would be 3, the bottom number would be 12, 24, which we could reduce down to, divided by 3, 1/8. As a percentage, that would just be top number divided by bottom number, or 1 divided by 8, and we would get 0.125, which is basically 12%. Or with the 5 there, we could probably even round it up to 13%. Okay. Now with the tree diagram, here's what we're going to do. We're going to draw a set of branches for each one of these, and at the end we're going to count up all the possible outcomes that we could have and see which ones get us this. Okay, so we're going to start off with tails and heads for a coin. Okay, and give yourself plenty of room when you make one of these. So my tree diagram is going to start out like this. I've got 2 possible things that could happen at the beginning. I could flip a heads or I could flip a tails. Okay. Next, we go to the coin, or not the coin, the dice. Even number on a dice. We've got 6 possible outcomes on a dice, so I need to draw 6 branches. So from this first one, I've got 1, 2, 3, 4, 5, 6. I could also have, if I would have got a tail the first time, same thing. 1, 2, 3, 4, 5, 6. The possibilities that you could get a 1, a 2, a 3, a 4, a 5, and a 6 up here. You could also get a 1, a 2, a 3, a 4, a 5, and a 6 down here. Okay? We're not quite done yet because we have to do the last one over here. So what we're going to do is you have to make each one of these as in you could get a head or you could get a tail. Okay, so I'm going to draw 2 branches off each one of these. And again, like I said, you're going to need a lot of room to make these. Maybe a full sheet of paper for each one, especially the ones that you're going to do a little bit later. Okay, each one of these, head, tail, head, tail. And I'm going to go through the whole thing here because those are the possible choices that you can get. And if you can't see this very well, I'm just putting an H and a T because those are the chances that you actually have to get. Head, tail, head, tail, head, tail, head, tail. Okay, now, everything we could possibly get by flipping a coin, rolling a dice, and flipping the coin is listed here. You just have to follow the tree diagram. So if I start at, if you just follow the branches, let's say here this branch would be you flipped a head, this branch would be you got a 5, and this branch would be you flipped a tail. Okay. Now we're just interested in what we need to actually get here. So we can narrow this down pretty quick. We have to get a tail on the first thing. So that means that this is the path we're going to want to take. We couldn't go up here at all, so these are all out because our first thing would be a head here. So these are all out, which makes it nice because we can narrow it down a little bit. Okay. Now we have to get an even number on the next one. Okay. So 6, 4, 2. Okay. So we've got those branches. And now we have to get a tail on the next roll. We don't have to worry about all the tails, only the ones that came off of the even numbers. So we've got tail here off of our 4. We've got tail here off of our 6. We've got tail here. So basically, we're trying to figure out how many different outcomes got us tails, even number, tails. So let's look on here. if I follow the path, 1 gets me all the way to the end, tail, 6, tail. This one gets us all the way to the end, tail, 4, tail. And this one gets us all the way to the end, tail, 2, tail. So that's 3. 3 different outcomes at the very end. Now at the end we just have to count up how many total outcomes we have. So we count the end of each branch. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24. 3 out of 24, which is exactly what we got up there. Narrow it down, reduce it, 1/8, which is still, if I do 1 divided by 8 on a calculator, going to be 12 or 13%. So it's just all about making sure that you've got everything on your diagram. You just go piece by piece by piece, making your branches, and make sure you have plenty of room. Alright, I drew this one up first before we talked about it because it's a pretty big example here. What I did was math classes in high school, your choices. Okay, when you're a 9th grader, you've got a couple of different choices for math classes. If you're a 10th grader, 3 choices. 11th grade, you've got 3 choices. 12th grade, you've got 5 choices for math classes. So the question is, how many different combinations of math classes could you take in your high school career? Now, I've started off with just the basic way to figure it out at the bottom as far as how many chances of each one you have and multiply them together like we've done before with any of the other examples. If there's 2 math classes, you've got a 1 out of 2 chance of taking one of them. 10th grade, 3 choices, 1 out of 3. 11th grade, you're going to take 1 out of 3. And 12th grade, you're going to take 1 out of 5. If I multiply them all together, your total number of choices for math class combinations is 90. Okay, you've got 90 different combinations you could take. Now, if I look at this tree diagram, basically what I've done is I've taken the first branch to go with the 9th grade and split it up into 2. 9th grade 1, 9th grade 2. Off of each one of those, I went to the 10th grade and did 3 for each one of those. So I did 10th grade 1, 10th grade 2, 10th grade 3, 10th grade 1, 10th grade 2, and 10th grade 3. Now, here's where it gets a little bit more tricky. Off of each 10th grade one, there's 3 more 11th grade choices. So there's 11th 1, 11th 2, and 11th 3. 11th 1, 11th 2, 11th 3, all the way down. And then the last one I couldn't even fit all the way on the board, so I just wrote it out like this. I know that there's 5 12th grade choices. 5 12th grade choices. So off of each 11th grade choice, I just drew one line, but I put a 5 there knowing that there's 5 different choices. Okay. Now we just need to know the total number of possible choices you could have. I could follow each one of these lines, but really all you need to do is count up the total at the very end off the branches. Now normally off of this one right here I would have 5 lines, but I just drew a 5 there because I couldn't fit 5 lines for 5 different classes. So all I need to do is count the outcomes, and each one of these lines now is going to stand for 5. So I go 5, 10, 15, 20, 25, 30, 35, 40, 45 here in the first branch, 50, 55, 60, 65, 70, 75, 80, 85, 90. So I've got 90 different choices, which if you look down here, that's exactly what our number was telling us down here too. This is just a way to prove that we have that many number of outcomes.